So one of the questions that came in from the audience, which was really from a US perspective, was what are some of the main reasons that production of a given element is low in the US or the EU? I'm sure this applies elsewhere. Is it lack of reserves? Is it regulations or trade rules making production less competitive or attractive? Or is it incomplete exploration of potential resources or something else or a mixture?
I believe it's all of the above. So in some cases, geologically, the United States might not have the significant reserves. So think of bauxite or tantalum. In other cases, it makes, there's just economic comparative advantage for other countries to produce it. In other cases, it's simply lack of exploration. And so I think it's a combination of all of the above. And so tackling these, if one were to reduce import reliance, you would have to look at them on a commodity by commodity basis to address that question.
Well, from my perspective, no country has all the elements or minerals it needs. As Al said before, what we are seeing now is that the industry and the technological developments require much more metals and a wider number than it happened in the past, meaning that in fact trade seems to be the only solution because, as I said, no country is fortunate enough to have all the minerals it needs. But in some cases, we have the minerals and we cannot export the minerals. This is clearly a problem in Europe because there are many conflicts on land use, and we are also facing a bigger issue with the sterilization of resources. And this happened because in this 1983 G7 summit, when the people from these countries, many of those countries are from Europe, Italy, France, the UK, Germany, and so they decided that it will be much easier to outsource these minerals from developing countries instead of mining them from Europe. And this has at least 2 or 3 advantages. First, they were not so expensive. Second, it solved the problem of the, let's say, ecological groups that were protesting against pollution, and finally, it also gives the developing countries a fair opportunity to develop. So in this context, we ended up 30 years later with, in the case of Europe, with people that is not used to mining, which doesn't realize the importance of minerals and the importance of mining, and normally they oppose mining. And this explains why when we are facing land use constraints, normally the decision is in favor of the other uses, or if you prefer, against mining. So in some cases we have the minerals, but we cannot reach them.
Thank you. So one question that came from the audience was, what are some of the largest sources of uncertainty in quantifying the production and trade of critical materials, and how can these be minimized?
So that's a really good question. So we believe we have a pretty good handle of mineral production throughout the world. This is a primary function of our center, the National Minerals Information Center. Some commodities are obviously more well-known than others. We have a really good handle on the bulk commodities. Some of the minor metals, the production is much more difficult to get a handle on, but I think we do as good of a job as anybody. A lot of it also is whether or not the company's data is withheld or if it's a private company. A lot of the stuff that is going on in China is, of course, hard to discern and hard to verify. So that's on the case of production. In terms of trade is also is much more difficult than I think production, because in a lot of cases the trade statistics are not very clear. In some cases they combine several commodities into a single trade code, and so it's very hard to discern how much is being traded. Not all the countries report all their trade uniformly, so that could always be a challenge.
Okay, from my perspective, the biggest uncertainty comes from the future. If you want, there are, again, in my opinion, there are basically 3 main drivers of change. One is technology, so the technology or the technological developments. The other is the social and political factors. And the third factor of change, a new one, as I said again, in my opinion, is climate change. Of these three factors, well, the social and the political, you can have a fair idea of the near future, sometimes with surprises, as we have recently seen in the international arena from the political perspective. The climate change, it's also bringing a lot of raising a lot of problems, also bringing many challenges. But I would say that the technological factor is the most difficult to access, because all these informations, as I said before, in the case of the European Union, we are using statistical data on trade, on the value of a specific mineral to the European economy. But the problem is that we are looking to the past. So we are using statistical data. And that I'm aware, I've seen from Nadal presentation that the US is trying to have this proactive perspective on new technologies and the materials that will be used in the future. I do know that Japan is having a similar approach. So they work, I mean, the government works closely with the biggest companies to try to understand what's in their technological development pipeline. But this is not the case in many times. And some disruptive technology might change completely the scope or the needs on critical raw materials. Probably the best example now on the table is lithium, and if you want, sodium. So if this technology that will be using sodium in batteries in the future will advance and becomes feasible, then all this need of lithium will be gone, because lithium will be back to the uses in ceramics and basically being used as an industrial mineral only. So technology is, in my opinion, the basic factor and determinant.
Thank you. This is a fairly long question, but the gist of it is that bulk construction materials have potential supply risks and suppliers coming under stress in some countries. The question was coming specifically from the UK. And the question is, are bulk construction materials used in these studies, given that these supplies are coming under stress and that some of the indicators are going in concerning directions? Recognizing this kind of supply risk early would be better than waiting until all criticality criteria are met. So I'm wondering if you could speak a bit more broadly about perhaps minerals that aren't viewed as critical yet, but that are tracked regardless.
Yeah, and so we hear this concern quite often. The focus of the studies are typically metallic minerals. So we typically don't look at industrial minerals in this way. I believe they are, quite different. A lot of those concerns for industrial minerals are local or regional issues, where metallic minerals are traded globally, so the issues are much more global. It's not to say that we can't examine them or we shouldn't examine them, but thus far the focus has been mainly on metals and metalloids and trying to understand their supply chains.
Well, this is a very interesting question. To make it shorter, let's say the direct answer is no. I mean, construction materials are not considered in these criticality assessments. However, I agree that construction materials are critical for several reasons. The first one is that employment and all the trade associated to construction is in many countries much bigger than the importance that we have with the metals. I mean, the social importance. Even that's one of the reasons why construction materials are also named development materials especially in developing countries. I believe that this is not on the radar of the European Union. I believe it will be very difficult to put it there. Again, people believe that if, in the case of construction, if you are using recycled material, this will be okay. so I don't know exactly how this will evolve in time. I know already that there are countries like India that are facing that are facing heavy problems with the supply of some construction materials, very basic construction materials, such as sand, meaning that they might be critical in the future. From my perspective, this is not in the radar of the European Union.
Great, thank you. Another question that came in is, what is the predictive power of these activities? And specifically, what is a realistic time frame over which projections of criticality may be useful?
Yeah, that's another really good question. So in general, we look at our assessments as having a medium time frame. So we're not looking at things that are short term, like what's going to happen next year, and not necessarily for the criticality assessment, what's going to happen, in 50 or 100 years from now. So we're looking at something in the medium range. We're looking for trends that might suggest that, in 5 to 10 or 20 years, this is trending in the wrong direction. In terms of predictive power, the screening tool is designed to try to minimize sort of false positives and false negatives as much as possible. We're trying to develop a way to sort of validate using historical examples and tweak the analysis to be more powerful. In terms of the analysis that we have looked at to try to do that, it is quite able to anticipate, for example, the rare earth crisis before it occurred. And so we're looking at using more historical case studies to try to verify and validate the model and tweak as necessary to reduce these false positives or false negatives. But you're never going to be able to go from a list of 70 commodities to a perfect list of critical commodities. And so the approach that we've taken is this sort of two-step approach. You sort of do a rough screening, which is what this is, looking at broad indicators of what's going on in the market, to sort of narrow it down to a subset of commodities that you think need further examination, which is what I was hinting at with the tantalum example. Okay, we've highlighted tantalum as a potential concern. Okay, let's dig deeper into it, figure out what's going on in terms of how is it being used, how much is being recycled. And then, of course, the effort needs to continue. If it's deemed critical, we need to have programs like we have in the United States with DOE's national labs doing the Critical Materials Institute, doing studies on recycling and substitution and developing those efforts. Those are really important and need to continue.
Again, from my opinion, and I hope I'm not hurting someone's feelings, my perspective is that predictive power is becoming lower and lower. Just let me give you an example. 2 years ago, I was working in a project, the intro project. The observatory was working on scenarios, political scenarios linked to raw materials, and it was like the Brexit and the election of Donald Trump and the impact this has on politics and nationalism and free trade agreements, etc., was something that we consider in a very distant, I would say, perspective. It was something that, well, it's probable, but not so probable. So I believe the predictive power is becoming lower and lower because it's much more difficult nowadays to predict the near future. And this happens because all these new trends are impacting each other, and the unrest, the political unrest, the social unrest, and the technological unrest. And if you put on top of this the climate change, are making this time frame shorter and shorter. The European Union is now using a 3 years time frame. I believe that going more than, let's say, 1.5 years is too much. And the problem is that the assessment it takes time to prepare. So it's very difficult to make an assessment every year or every 2 years. For the time being, it's being made every 3 years. But I'm absolutely sure that people working on this, they are fully aware that change might happen any moment. So the radar is open, and the eyes are looking closely to trends.
Thank you. All right. So one question that came in was that the EU approach seems to accommodate a wider range of policy responses, substitution at the mineral level, substitution at the product level, and at the product level, redesign of processes and products to reduce demand for critical minerals. How are these policy responses addressed by the USGS criticality screening, if at all?
So in general, the screening tool is meant to be just that, a screening tool to try to sort of reduce the number of commodities that we look at to a subset that we then further study. In terms of policy responses, I'm sure folks have seen the executive order and then followed by the secretarial order on critical mineral supply chains. And so as part of those orders, there will be a policy response that's led by the Department of Commerce. I'm sure that a lot of other agencies will also be involved in helping to draft that report. But substitution is one of the key aspects that will be examined as part of that, as well as other responses. In general, the USGS, of course, is a science organization. We do not deal with regulation or policies directly, but we hope that our science does inform policy. As I mentioned before, there's already an ongoing effort in the United States to address substitution as well as recycling through the Critical Materials Institute. At the USGS, we also have significant efforts going into mineral resource assessments. And so those are the things that are currently going on in the US government.
Great, thank you, Nadal. Our next question was, we'll probably need more people who are qualified to do this sort of analysis. What is the best kind of educational background for this? Geology, economics, other subjects, a combination?
So I think there is no single background that is the only one needed. I think we sort of need all of the above. The group that I lead includes both people with geosciences background as well as mineral economics. I am perhaps the only industrial ecologist at US Geological Survey. I perhaps am wrong, but I think we need people who are able to have both a depth and as well as a breadth of expertise in a lot of different things, because this does sort of span the sciences, whether it is from geology, economics, as well as on actually being able to implement things in terms of the engineering, material science, and engineering side as well.
Well, this is really a very good question. It's difficult to answer. I would say that geology is important because it provides you the basis, so you have a common understanding, and sometimes we have seen this recently with the meaning of words. I mean, a good example is the word resource, that in life cycle assessment has a meaning, and in minerals reporting has a completely different meaning, and sometimes people is misusing these terms. So geology is important. Economics is of course important. I believe the other subjects like political sciences and I would say an open mind to understand the impact of technology changes are probably the most important. But this is my conviction. I do believe that the change or difficult factors that we need to consider in these assessments are the ones that came from technology changes, as I said before. And for this type of assessment, you might be working on geology or in economics, but sometimes it just happens because you are too focused on that, you are an expert on that, you might miss the big picture. So you are an expert on the tree, but you miss the forest, meaning that a wider approach is better than an experts only approach. The best way to deal with that is to have a team with people coming from many different specialities and types of education.
Great, thank you. I will go on to another question, which is there anything happening at the federal or state level to increase the recycling of electronics in the US? Is that something you could speak to?
I can just speak briefly to this. This is not an area of expertise in terms of understanding exactly what programs there are, but there are a significant number of programs out there, mainly I believe at the state level, trying to understand and being able to collect consumer electronics at the end of life. There's also initiatives regarding extended producer responsibility. And so there's quite a bit going on. My understanding it's mainly on the state level, but I could be wrong.
Okay, thank you. We'll go into another question, which is coming from an undergraduate economics student. which is what kinds of processes might affect the below ground availability of certain elements? So why might some elements be found in one place or not another?
Well, I could try to answer it, but I'm not a geologist. So I mean, at the end of the day, it comes down to minerals concentrate in different locations. They're not uniformly or randomly distributed. So the concentration of minerals is of course important. The economics of being able to recover that mineral, are they at the right ore grades? Are they in favorable locations? There's a lot that goes into play whether or not those minerals are eventually deemed feasible, and a lot that's done in terms of exploration to understand that before any significant amount of investment goes into place.
Okay, I do like this question because let me say that I started working as a mine geologist, and the first time I visit mines that were exploited in Roman times, I was amazed by the small size of the galleries. It was later explained to me that these galleries are small because the Romans used child labor, if you want, child slaves to do the exploitation of the mines. I do believe that a big change will probably is in the near horizon, and this will be pushed by the change on the scale of mining, and it probably will be delivered by robotics. What's happening now is that we are opening a mine, and the size of the gallery, in the case of underground mines, needs to be big enough to have the equipment and the people. In the case of open pit mines, you are open huge pits because you are trying to increase the productivity by having large dumpers and excavators. But this has problems because the cutoff ratio, the amount of materials that you need to dig, etc. These are the side problems that came with this increase of productivity. I do believe that in the future, robotics might change the game. Because with robotics, instead of, if you are looking to a specific metal, let's say in a quartz vein, you don't need to take everything out and then to mill, to crush and to mill to take out that metal. If you have, again, in the future, this type of, you can call it for a visualization, something like an ant robot capable of going to very deep levels, then you are changing clearly the game. And this can also provide you a solution for deposits that exist in populated regions. Again, I'm talking about the European example, and even below a city. If the mine is using very small scale elements, it became virtually invisible.
Thank you. Nadal, there was a small question from, I think, someone at the US Geological Survey asking if you could talk about the infographic that you posted yesterday at the USGS on import reliance to US Navy gear.
Sure. This is something that was just posted yesterday on our website. It is a new infographic that we put out to sort of bring home the message of import reliance. So as I mentioned in my talk, we put out in our mineral commodity summaries every January the latest information regarding U.S. net import reliance. But in order to make that message sort of resonate home, we've done a number of these sort of infographics or fact sheets. Previously, we had done one on looking at the content of cell phones. This year, we decided to look at what kind of commodities go into Navy SEAL gear, and so we put out a fact sheet looking at that. And there's something on the upwards of 24, at least 24 mineral commodities that go into Navy SEAL gear for which the United States is at least 50% import reliant in 2016. And so it's everything from night vision goggles to battery packs to communication gear to global positioning system. So, and that's just, one example of net import reliance.
Great, thank you, fascinating. We'll move on to another question now. On the critical minerals screen, the periodic table that you showed, it looked like scandium showed a blank. given that there's significant interest in scandium from aerospace and defense sectors? Is this is it missing for a reason?
Right. So scandium is obviously something that is of interest to a number of people. We didn't feel we had the sufficient data to do the analysis for scandium, but it's something that we hope to do in the future if we feel confident in the data we're able to collect.
Great, thanks. All right, next question. Are any of your affiliated organizations or any other organizations that you may know of able to track the level of research going on into the recovery of critical materials from mining waste stocks, including coal, fly ash, common metals, etc.?
Right. So there are a number of critical minerals that are contained in coal, fly ash, as well as mine tailings, for example. There's, I believe, I'm trying to remember exactly the way it is. There was maybe a call for proposals from DOE that asked for researchers to look into recovering rare earths from coal fly ash. That's not something that we have, at least at the National Minerals Information Center, have dug into deeply. I believe that most of our information is regarding what is going on from primary deposits. I have previously looked at, how much is contained in mine tailings in my previous work, but that's not something that we regularly report on at the National Minerals Information Center.
From my perspective, there is a huge gap in this activity, meaning probably for different types of reasons. Sometimes because the research came from different areas. A good example is the people working on bioleaching. They came from the biology sector, not necessarily from the geology sector. And that information is not exchanged between these two different groups. And of course, we have the silo mentality also. And on top of that, you have the need to protect your research. So in many cases, people is doing research. There are duplicated research, and research teams, they do not cooperate among themselves. One of the, let me just say this, one of the tasks that we intend to develop below the International Raw Materials Observatory is this type of cooperation between research centers and organizations. So they have a minimum information on what the others are doing, and this might be, let's say, the trigger for more cooperation. So instead of trying to replicate or invest a huge sum of time and effort on something that is already advanced by others, it might lead to some type of cooperation efforts.
Thank you. We'll go on to one more question here before we finish up at the end of the hour, which is, how well equipped is the US with recycling electronics? And what are the kinds of challenges associated with electronic recycling?
So there are a number of challenges, and I think the most important one is simply, and this is not just for the United States, this is globally, simply a lack of collection. So if the consumer good is not collected for recycling, there's, none of it's going to get recycled. So that is a significant problem. The logistics of it, how you make it economical to be able to do that is important. Miniaturization is also a potential problem. So as technology and electronics specifically become smaller, per unit, they're using less and less of a specific commodity in that unit. So the amount of tantalum per capacitor, for example, has been declining significantly, which of course makes the economics harder, because if there's less of it in there to recover, then it's less economically of interest to recover. So most of the electronic recycling that goes on is typically for copper, gold, and other precious metals such as palladium. So even at the best recyclers in the world, for example, Umicore, that do electronic recycling, they are getting a significant amount of other metals out when it's economically feasible to do so. In a lot of cases, the electronics don't end up going to those places and end up being recycled in other parts of the world where they might not be using the best technologies, and thus they perhaps only recover a few elements. Probably gold is what they're going after, and of course they're doing it in situations where it's not necessarily the most beneficial for human health, so it causes a number of problems. So that's sort of the state of the situation at this point.
Just let me complement Nadal answer and perspective. Basically, logistics is the critical issue here, and in that particular aspect, I do believe that the European Union is well equipped. Not so well equipped as Japan, because Japan has the most efficient, let's say, recycling. They control all types of metals and elements flows, and they recycle almost 98% of all materials, which is something that is in a way far away still from the European horizon. However, economics is the key point, but we also see trends that will probably put a deterrent on recycling, and one of them is the efficient use of materials, meaning that many companies are now producing products that have every time a smaller amount of the critical raw materials, as Nadal just said. A good example of this is with the nano coatings. The nano coatings, for instance, if you want to have in your mobile, instead of a very small amount of gold in a particular electronic piece, if instead of that very small amount, which is already very difficult to recycle, you have in case of if you have instead a nano coating of gold, then recycling is virtually impossible. I mean, it's very, very expensive to do it, and basically that gold will be lost forever. Of course, we are talking about gold, we might be talking about tungsten or vanadium or any other critical element. So in a way, it seems like the trend to advance a more efficient use of materials with less materials, critical raw materials incorporated in the objects, in the products. It's also something that makes the economics of logistics much more difficult to achieve, and in a way it might make the materials used virtually and impossible to recover and lost forever.
Thank you. So we're coming up on the hour here, and so we'll wrap up this webinar. If you had any questions that weren't responded to today, we'll also send those on to the speakers, Nadal and Vitor, for their responses, and we will get back to you on the answers to those questions when we have them from the speakers. Thank you very much, Nadal and Vitor. This will conclude our webinar for today. Thank you for joining with us, and we look forward to seeing you next time.